Dr. Ranjani Parthasarathy is a professor in the Department of Information Science and Technology, Anna University. Her area of specialization is computer architecture and networks. One of her special interests is Indian language technology systems. She is actively involved in research in all the areas and has over 50 publications to her credit. She has about 25 years of experience covering both industry and academics.
Welcome to the UGC lecture series in computer science. We are looking at a series of lectures in computer networks. Today we will be looking at application layer protocols, and in the application layer protocols, today's topic will be on domain name system. We will be looking at both the functions and the details of this protocol. So the point we are looking at is, why do we need these domain names? Now we know that whenever we try to access anything on the network, we first specify something like www.google.com or www.annainu.edu. These are the names that we specify. These actually refer to the domain names, and in terms of networks we also know that every node is identified by means of its IP address. So from what we have learnt in terms of the transport layer protocol, network layer protocol, data link layer protocol and so on, we know that in an internetworking scenario, nodes are identified by means of their IP addresses. So now typically I would like to remember, if I want to specify a particular node, I will have to specify its IP address. But for us it is difficult to remember IP addresses. So we use names which are alphabetical, which have alphabetical characters, easier for us to remember these names, and then we have a system which translates from this alphabetical name to the IP address. So it is easier for us to remember domain names rather than IP addresses, which is the reason why we use these domain names. And the system which helps us to do this conversion between domain names and IP addresses is the domain name system. So we say that the domain name system is the system that translates between domain names and IP addresses. The way this domain name system is designed is in terms of an internet-wide distributed database. So that is what we need to understand, how this distributed database system is implemented, so that we are able to do this translation between domain names and IP addresses in a proper manner. So let us look at, so I said distributed database. So what do we mean by this distributed database? What we are talking about here is that this entire domain name system is implemented in a hierarchy of many name servers. So we have many name servers which are located around the globe, and this domain name system is implemented as a distributed database on these name servers. Plus, in addition to this distributed database, we also have an application layer protocol which allows hosts to communicate with these name servers, and as part of this communication they resolve the names. The term that we use normally here is resolving the names. What do you mean by resolution here? Resolution essentially identifies that given an address, you get given a name, you get the corresponding address, IP address. So this address to name or name to address translation is what we mean by saying that we resolve the names. So we have a distributed database and we have an application layer protocol which allows these name servers to communicate with one another. Now what we have to understand here is that this is actually a core internet function, because you are looking at identifying a machine by means of its IP address, but it is actually implemented as an application layer protocol. So which means that the complexity is shifted to the network's edge rather than doing something in the core of the internet. So how important is this DNS? So this question is very simple to answer. Just imagine what happens when the local DNS server is down. So what would happen if your local DNS server is down? We know that whenever we are accessing the machine, if your local DNS server is down, for instance you get some, you try to access a page and you get a page not found message. Now when you find that before you get this page not found message, you will often find that if the local DNS server is down, you will get also a message which says that you are unable to access the local DNS server, or it will say DNS access failed. In fact, if you look at the details of why you are not getting your page, you will find that it is the local DNS which has failed. And if your local DNS has failed, none of the web pages you will be able to access, because you are not able to go past your machine into the internet at all, because you are not able to resolve any of the names to the corresponding IP addresses. So this is just to say that DNS is one of the most important protocols that are required in the network, so that we are able to access the services of the internet. Okay. So what happened before there was DNS? So let us take a look at that. Before there was DNS, we had the hosts.txt file. That is, we did not have a distributed domain name system, but we had just a simple file which contained this mapping of domain names to IP addresses, and this particular host.txt was just downloaded from a central server and given to different machines. So, until about 1985 we just had this kind of a single file, and this was downloaded by means of an FTP protocol from a central server, and the names in this host.txt were not structured, and though this host.txt file still works on most operating systems, it is not scalable. Okay. So, it can, so but still it is used for defining local names and so on. Okay. So, this is how things were before the distributed domain name system was put in place. So, if you look at the centralized DNS kind of a mechanism, the problem with whenever we have a centralized system is that we can have a single point of failure. So, what we mean by a single point of failure, you have a central node from which you are accessing data. So, that central node fails, then the entire system fails. So, this is one of the problems that we always have with a centralized mechanism. Second thing is traffic volume. So, when you have a centralized, a single DNS which is serving all requests, so the volume of traffic that it has to handle becomes very high. So, that is a problem. So, if you have a distant centralized database, again it is the distance that can cause a problem, because you need to keep sending traffic to that centralized database, and you have the time taken will vary, and again combined with the traffic volume, you may find that it takes too much of time before you get back the response to your request. That is a problem. The fourth problem that we have is maintenance. In fact, you can look at it both as a problem and as not so much of a problem, in the sense that you only have one central database to maintain. But if that one central database fails, then we have a problem. Okay. Overall, you can summarize what is the problem with the centralized mechanism. The major problem is that it does not scale. So, what we mean by scalability, that is when we increase the number of nodes that need to be supported, as we increase the size of the network, as we increase the number of IP addresses that need to be resolved, we find that having a centralized DNS does not really scale well. So, which is why we go in for a distributed database system. So, let us look at the design principle of this distributed domain name system. So, what we have here is we have a naming system which is based on a hierarchical and logical tree structure called the domain namespace. Okay. So, and an organization obtains authority for parts of the namespace and can add additional layers to this hierarchy. So, what we are doing here is that the names of hosts are assigned without regard of location on a link layer network, IP network or autonomous system. So, we really do not worry about where exactly it is located, but you can have names assigned appropriately. And in practice, the allocation of the domain names is such that it follows the allocation of IP addresses. For example, all hosts with network prefix 178.143/16 can have the domain name suffix annauniv.edu. All hosts on the network 178.143.136/24 could be in the computer science department of the university. So, you can see the what we are talking about over here. Now, annauniv.edu is what we mean by the domain names. Now, edu is a domain, is part of the domain namespace. Annauniv is again part of the domain namespace. Now, edu may come under the control of a particular organization. Annauniv.edu would come under the control of another organization, and when you talk of 178.143.136 as the an internet address of the machines which are there in the computer science department of the Anna University, you could also have a domain name which says cs.annauniv.edu, which would come under the control of the computer science department. So, you can see that we are having different namespaces, or this is what we mean by a hierarchical namespace. We have edu at one level, we have within edu you have annauniv.edu, and within annauniv.edu I could have cs.annauniv.edu, ece.annauniv.edu and so on. Okay. And if you look at the mapping or the correspondence between the IP addresses and the domain names, we see that 178.143 refers to all the nodes which are there under annauniv. In this I have a subnet which is .136, which is indicated by .136/24, and this would correspond to cs.annauniv.edu. Okay. So, you can see that between the IP addresses and the domain names there would be some kind of a correspondence that would exist. So, now if we look at the typical organization of the servers, this is what it will look like. So, you will have something called a root server. So, you can see that there is a tree like structure here. There is something called a root server, and under this root server there would be different domains that we talk about. Now, these are what are referred to as top level domains, that is they are at the top level. If you look at different levels of this tree, these are at almost the topmost is the root, is right next to the root. These are called as the top level domains. So, the top level domains you will have something like edu, com, us, arpa and so on. Okay. And within this you will have the different other within the edu server you may have something like fhta.edu, annayanu.edu, bk.edu and so on. Similarly, under the com server you would have various things like mcgraw.com, irwin.com, whatever, right. So, different servers would exist. Okay. And what we mean, and corresponding to the names that we talked about, you would have servers there, right. So, we talk about root DNS server. Under the root DNS server you have various servers, the com DNS server, org DNS server, edu DNS server and so on. These DNS servers in turn will have information about the different servers which exist under them. So, you have poly.edu, umass.edu and so on. So, under the org server you may have pbs.org DNS server and so on. So, you can see that the information about this mapping between the DNS names, the domain names and the IP addresses is what would be maintained at these servers, and these servers you can see would know how to interact with one another, and you can see that there is also a distributed structure over here. So, and a hierarchical structure over here. So, this distributed hierarchical structure of this database is what is exploited in order to obtain information correctly from the correct server. Okay. So, that is now what we need to look at is how the DNS the application allows this to happen. So, let us say for instance, a client wants the IP address for www.amazon.com. Okay. As a first approximation, let us look at what will happen. So, the client would typically query a root server to find the com DNS server. Now, note that when we are processing the domain names, we typically start from the end, from the right end, right. So, what you are first looking for is www.amazon.com. So, com is the first domain that you need to find out. So, the client will query the root server to find the com DNS server. Okay. So, then once it gets the information about where the com DNS server is located, the client then could query the com DNS server to get the amazon.com DNS server. Okay. So, once the amazon.com DNS server has been contacted, then information has been obtained, that is contacted by means of by the client. So, the client queries amazon.com DNS server and gets the IP address for www.amazon.com. So, this is typically what would happen in this distributed hierarchical database if the client needs the IP address of any machine. This is a first level approximation. There are of course ways in which this access can be optimized. Okay. So, we will look at how that is also done. So, you can see let us just kind of summarize what we are talking about. Now, when we talk of DNS, we talk about just as I said now different types of servers. So, first thing we talked about was a root name server. So, now this root name server is contacted by the local name server that cannot resolve the name. Okay. Now, what is this local name server? This is typically a name server that is present in every organization, which is responsible for contacting the different name servers which are there in this distributed database. Okay. So, this root name server is the one which contacts the authoritative name server if the name mapping is not known. That is, the root name server may not have all the information, but it knows how to contact the next level server. So, it will contact, so it has information to contact the authoritative name server if the name mapping is not known. So, it gets the mapping and returns the mapping to the local name server. So, this is what is done by the root name server. So, then we have the top level domain and authoritative servers. So, the top level domain servers are responsible for the second level that we talked, the top level that we talked about, right, com, org, net, edu, etc. And we have domains for all top level country names, country domains. So, you have UK, FR, CA, Japan, IN for India and so on. Okay. Then we have the authoritative DNS servers, which are responsible for the organization's DNS servers, and they provide the authoritative host name to IP mappings for organization servers, for example, for web and mail and so on, and these can be maintained by the organization or the service provider. So, this gives us a top level view of what are the different types of servers that we have in this DNS. We take a small break now and come back and look at the details. Yeah, welcome back after the break. So, we are just going to take a look at the details of the different domain servers that we have been talking about. So, let us look at the top level domains. So, there are actually 3 types of top level domains. You would have seen these 3 different types in the discussion that we had just now, but just to look at that explicitly. So, first thing that we have is organizational 3 character code that indicates the function of the organization. The first type of top level domain is an organizational domain. So, we can see what we have here. This is used primarily within the US. You have these 6 different terms that are used: GOV for government, MIL for military, EDU for educational organizations, ORG for other organization, COM for commerce, NET for network service providers, and so on. Initially, in fact, these were the only 6 domain names that existed, because initially this entire thing was designed and used in the US, and they came up with these different 6 different domains depending on the purposes for which it was supposed to be used. Okay. So, then of course, later a geographical top level domain was added. So, this is now a 2 character country or a region code. So, you have US, VA, JP, DE, IN for India, and so on. So, you have different, so these 2 different types of top level domains. These are the 2 that you would normally come across. Okay. The third type of domain that we have is what is called as a reverse domain. Now, this is actually a special domain. For instance, you have in-address.arpa. This is used for IP address to name mapping. There are some more than 200 top level such domains. So, this is the reverse, it is called as a reverse domain because here given an IP address you find the corresponding domain name. So, it is a reverse of what we are normally doing in the case of domain name to IP address mapping. Okay. So, the one that we are normally concerned with are these 2, organizational and geographical. Okay. Okay. Now, if you look at the organizational top domains, as I just said, COM refers to commercial organizations, EDU refers to educational institutions, GOE is used, V is used for government institutions, INT for international organizations, MIL for military institutions, NET for networking organization, and ORG for non-profit organizations. Now, the next thing we look at is the local name server. So, we looked at the root server and we looked at the top level domain servers. Now, we are looking at the local name server. Now, when we talk of the local name server, this really does not strictly belong to the hierarchy. It is not part of the hierarchy, but each ISP, internet service provider, whether it is a residential ISP or a company or a university, has a local name server. Okay. It is also called as the default name server. The reason why we have this local name server is that the different machines which are there in a university or a company, each of them need not contact the root name server. Instead, they could just first contact the local name server, and the local name server then in turn will contact the DNS server. Okay. So, when a host makes a DNS query, the query is actually sent to its local DNS server. So, this local DNS server it actually acts as a proxy and forwards a query into this hierarchy that we talked about. Okay. So, this is again just a pictorial representation of what we talked about. You have the root, then you have ORG, EDU, GOV, COM and so on, and then we have within EDU you may have toronto.edu, math.toronto.edu, ece.toronto.edu. You can see that this ece.toronto.edu could be managed by the ECE department of that university. Toronto.edu would be managed by the University of Toronto, and these are top level domains which are managed by an external organization. Okay. So, this local domain name server that we talked about, for ece.toronto.edu there could be a local domain name server. So, now since this is managed by the ECE department, different nodes which are there in this department, when they need to access any need to do any domain name resolution, they would contact this local DNS which is located over here. Now, this root and top level domains are administered by what is called as ICANN, which is Internet Central Name Registration Authority. The ones which are coming under this, as we saw, will be maintained by their respective organizations or universities. Okay. So, we say, so therefore, below the top level domain, administration of namespace is delegated to the organizations, and each organization can delegate it further. So, this is the summary of what we have seen in terms of the domain namespace and how that is organized. Okay. Now, coming to the resolution, so we just said that we talked about the local the machine any local machine contacting the local name server, and then the local name server we said is responsible for getting the name resolved. So, we have to now look at details of how this thing takes place. So, typically let us say for instance from the HTTP protocol, let us say www. I've got a web browser, and from the browser I am specifying some address. So, what I have specified there is what is referred to as a host name. The host name in this example, say for instance neon.tcp/ip lab.edu, is the host name that is specified. So, the HTTP protocol, now the HTTP protocol needs the IP address so that it can continue with its process. So, the first thing the moment it is given a host name is that it will contact the resolver. The resolver then is responsible for contacting the name server and getting the IP address back from that. Once it gets the IP address back, then it passes it to the HTTP application or whichever application had requested this. Okay. So, we can see what is actually happening here. The user program will issue a request for the IP address of a host name. The local resolver formulates a DNS query to the name server of the host. Okay. So, you can see what is happening here. DNS query is the term that to look at. So, the way the DNS information is obtained is by means of queries and responses. So, there is a particular format for this query. So, the local resolver therefore formulates this DNS query and sends it to the name server of the host. The name server checks if it is authorized to answer the query. If it is authorized to answer the query, that is, if it has the full information, it responds. Otherwise, it will query other name servers starting at the root tree. So, this name server of the host is the host to which this particular local machine belongs. So, you may be looking for a host name which is part of your own domain. So, in which case that can be handled by your local name server itself. Otherwise, it will have to go and contact the other servers and get the actual record for you. So, when the name server has the answer, it sends it to the resolver. Okay, this is the whole process. Now, in this process, we actually talk about two different types of querying. One is called as a recursive querying and another called an iterative query. Now, let us look at what this recursive query is. So, here when the name server of a host cannot resolve a query, the server issues a query to resolve the query, and that server in turn will send it to another server and so on. In iterative query, what will happen is when the name server of a host cannot resolve the query, it sends a referral to another server to the resolver. That is, it sends this query to another server and says, you get me the IP address. In this case, what happens is, in the recursive query, it sends it to the host will send it to that to the server and says, you get me the address of this particular query. I do not want to be concerned with anything more than that. In an iterative query, what happens is when a name server cannot resolve a query, then it sends back information to the root, to the local name server saying, I do not know how to reach this, but I will tell you a path through which you can find out. So, I give you a referral to another server. So, contact that referral server and get me the information. Okay. We will just look at how this takes place. And this type of query, whether we are using a recursive query or an iterative query, is determined by a bit which is specified in the DNS query. So, let us look at an example of iterative query. This example should make things quite clear for you. Suppose a host at cs.jnu.edu wants the IP address for nehru.cs.ninu.edu. Okay. So, the domain names servers we are talking about here are, this is a requesting host, this is cs.jnu.edu, this is located on this particular machine. So, this will contact then the local DNS server. The local DNS server is dns.jnu.edu. Okay. So, this requesting host, so first will contact the local DNS server. Then, right. So, the other name servers we have in the picture are the root DNS server, the top level domain DNS server, and then the authoritative DNS server for cs.ninu.edu. Okay. So, let us look at the sequence in which the requests are sent. The first thing that will happen is requesting host will send the message, a DNS request, to the local DNS server. The local DNS server does not have the reply, right. So, what it does is it goes and contacts the root DNS server. So, we start at the root. Okay. So, it contacts the root DNS server. Root DNS server may not have the full information. So, it now contacts the it does not have the full information, but it knows how to contact the edu DNS server. So, it sends back information saying, look, I do not have the full information of nehru.cs.ninu.edu, but I can tell you how to contact the edu server. So, now the local DNS server will send the same request to the top level domain DNS server, which is the edu DNS server. This again does not have the full details. So, it sends back information saying, I do not know how to contact the full nehru.cs.ninu.edu, but I can tell you how to contact annayunu.edu. So, now we have got the address for the IP address for annayunu.edu DNS server, which is the authoritative DNS server. So, now the sixth request, the sixth step is that the request now is sent to this machine, and now this has the correct information. So, this will send it back to sends the reply back to the local DNS server. Once a local DNS server now has the correct IP address for nehru.cs.annayano.edu, this sends the reply to the requesting host. Okay. So, you can see how this iterative querying is taking place. You keep iterating between the different servers until you get back the correct address. Okay. And this until you get to the authoritative server, because the authoritative server is the one which will actually have the correct address. So, if you look at a recursive querying, you can see what will happen. In recursive, for the same process, let us look at how this will take place. So, that is for the same request. So, cs.jnu.edu will now contact local DNS server. Local DNS server contacts the root server. Now, the root server does not send back reply to this, instead it contacts the top level domain DNS server, which is the edu server. Now, that does not have the information, so that will contact the authoritative DNS server. Now, this has the information. So, this now gives the reply back to the top level domain server, which in turn passes to the root server which had made the request, and that in turn passes it to the local DNS server, and that again passes it to the requesting host. So, you can see that this happens in a recursive manner. So, this is called as a recursive querying process. Now, so you can take a quick comparison between the recursive querying versus the iterative querying process. Look at what happens in recursive querying. In recursive querying, you are putting all the burden of name resolution on the contacted name server. That is, your local name server is the one which has to, the local name server passes the information to your to the root server, and then the root server is the one that is responsible for doing everything for you, right. So, heavy load on the root server. In iterative querying, the contactor server replies with the name of the server to contact. Okay. So, I do not know this name, but ask this server. Okay. So, in this case, the burden is with the local name server. Right. So, there are advantages and disadvantages to both, and you could use a combination of recursive and iterative querying to get the names resolved. The name servers cache information on domain name IP address mappings. So, when an entry for a query is in the cache, then the server does not contact other servers, it can just give the answer from the cache itself. So, if an entry is sent from a cache, then the reply from the server is marked as unauthoritative to indicate it is not actually coming from the authoritative server, but that is coming from the cache. So, with caching we find that we are able to reduce the traffic that is there for this DNS. Now, the information that is being sent back and forth, and how this information is stored is in terms of what are called as DNS records. So, we talk of what are called as resource records. RR is a term that is used. The format for this RR is like this: you have a name, value, type and TTL. So, the name specifies there is a mapping between this name and value, and the mapping between name and value is determined by the type field. So, you actually have 4 types of records that we have. You have an A type record in which actually consists this host name to IP address mapping. Then you have an NS type record, in which case name is the domain and value is the host name of the authoritative name server for this domain. That is, this is to point to the next server, right. So, that is the name that you have. Then you have a C name which is used for aliasing purposes. Then you also have a type called MX, in which case the value is name of the mail server associated with the domain, with the name. So, you can also use it for resolving mail server addresses. So, we have these 4 different types of records which are used, and the protocol uses the same message format for both queries and replies. So, information that we have here are the following: you have a message header which consists of an identification field, and then there are some flags which indicate whether it is a query or a reply, whether recursion is desired or not, whether recursion is available, whether the reply is authoritative. Following this, we have questions, which is a variable number of questions. Then you have answers, which is variable number of resource records. These are the RRs which are sent in response to the query. And then you have whether they are authoritative records from authoritative servers, and additional helpful information. Okay. So, this is how the information is sent between the different servers that we talked about. There are other DNS services also which are typically handled, which is host aliasing, which is done using the canonical and alias names. This is done using the CNAME records. Mail server aliasing, which is done using the MX records. And we also use load distribution by means of replicated web servers. That is, you have a set of IP addresses for one canonical name. So, what you could do is, given one canonical name, one www.annayano.edu, if there are multiple IP addresses, your domain name service can each time point to a different IP address, different machine, so that you are able to distribute the load. So, these are the different other DNS services which are supported. Okay. To summarize, what we have looked at is the need for DNS, the DNS hierarchy, iterative and recursive querying. And we also looked at the resource records and the use of caching. So, the questions to understand the topics covered today. What is the job of DNS? 2. What is a root server? 3. What is an authoritative server? 4. What are the two types of queries? 5. What are resource records? Thank you.